Let's look at our second video of transformations. Now, if you haven't seen the first video, that was looking at three different types of transformations there are. They are shifting, up, down, left, right. They can do a reflection or a dilation, a stretch or shrink. So in this video, we're basically going backwards. On number 7 here, we have to figure out what the parent function is of this graph. So there's a library of parent functions up here at the top. And I think number 7 here probably looks closest to a rational function. In fact, it is a rational function, but we still have to figure out what changed on that parent function. So the parent function is this f of x equals 1 over x. It's a rational function. To describe the transformations of the parent function for part B, one of the things I noticed was number 7 actually has the curves like on the opposite parts of the graph, which means that there was a reflection. So they kind of reflected it over either the x or y axis regardless, but say they reflect over my x-axis, that means that this bottom one got reflected and faces up, and the top one got reflected and faces down. So it was a reflection. Now I also noticed that the center of the parent function was at 0, 0, and the center of this one is actually at -1, -3. We had to have done some kind of shift. I would have to shift the entire graph to the left one, and I would have to shift the entire graph down by 3 to move just the center of the graph and everything else. Okay, one of the biggest mistakes I tend to see on this are dilations. So on my parent function, it is this diagonal of 1. It goes like over 1, up 1 to get to this point, and it goes like left 1, down 1 to get to this other point, which on my graph that I have now, if I want to actually hit these points, let's see, it doesn't go over 1, up 1. That would be right there. So let's see, I'm going to hit some points if I go like over 2 and down 1. Now keep in mind, it is a reflection, so I'd have to go like right 2 and up 1 to get there. Or maybe this other point I would go down 2, over 1, and again it is a reflection, so keep in mind I would actually have to go up 2 over 1 to get to my next point. So this is our dilation without the reflection or the shift left or the shift down. Just the dilation itself would hit these points. And so what did I dilate by? What did I multiply by? Well, 1 over x is my parent function, like 1 divided by 1 is 1, so that's what would give me this point. But some other number I can multiply by, divide by 1, and I get a 2. Well, I know that 2 divided by 1 is 2, so what if it's 2 over x? Let's see, so now if I sub in x value of 2, 2 divided by 2 is 1. Okay, yeah, that's correct. So it looks like they multiplied by 2. So I will say this is a vertical stretch by 2. And then part C, write an equation for the function on the graph. I'm going to have to maybe call it like g of x, give it some other name. We already talked about the 2 over x because of the vertical stretch, the dilation by 2. The reflection is going to require a negative, so I'm going to do a -2. Or you can put the negative in front of your fraction. It actually does the same thing either way. And then to shift it to the left, I need to go with the x's in the denominator because x's go left and right. So I would have to have x plus 1 in the denominator to shift it to the left by 1. And then to shift down 3, I have a -3, not with the x. It's going up and down like y values, so it'll be outside of the fraction, a -3. And one of the things you can do on this to kind of check your answer is you can put this in a graphing calculator, or you can go online, check it in like Desmos or GeoGebra, graph it, and see if you get the same graph. So that's one way to check and make sure. Last one here, if w of x equals this -square root of x plus 5 minus 2, what is the parent function? So first things first, I'm going to identify all the transformations. Let's see, I've got that negative, I've got addition and subtraction, those are transformations. Without the transformations, the only thing I have left is the square root of x. So they said to call it f, so my f of x function is the square root of x. That's the parent function. As far as the transformations go, again, I highlighted them. The yellow one, that negative, is a vertical reflection. And then the pink ones are both translations, like a shift. The 5 is in the square root with the x, so it is going to go horizontally like x's do. In fact, we had to shift to the left by 5. And then the -2, that's not under the square root, so it'll go like y's do, up and down. It will actually shift down by 2. Okay, so there are our transformations. And then the graph, I'm actually going to graph the parent function first. So the parent function of our square root function, which is up here. So here is our square root graph. It's got this little dot right at the origin. It goes through 1, 1. It goes through 4, 2, like the square root of 4 is 2. So I'm going to put some of those key points on here and graph just the parent function first. Here's my parent function. Now, to do all of these, I'm going to do like a dotted line for each of them. The reflection itself, vertical reflection, is going to go on the other side of the x-axis. So this would take care of our vertical reflection. And then you got to shift this whole thing to the left by 5. So 1, 2, 3, 4, 5. Shifting everything to the left by 5. Now we need to shift down by 2. Okay, so here is my final graph. I'll even put that in another color here. Okay, and I'm going to get rid of these. Purple one is my final graph. I just was taking it one piece at a time. Here is your final W of X graph. And then part D says to use function notation to write W in terms of the parent function, F. So the stuff that I highlighted up here, I'm going to put it on the F of X. There's a negative in front of that square root of X, so there's a negative in front of my F of X. There's an X plus 5 under the square root, so I'm going to put an X plus 5 in the parentheses. And then outside of that square root was a minus 2, so I'm going to put a minus 2 outside. So this is function notation in terms of the parent function. All right, let me know if you have any questions.